we'll pick up from where we left off. So in the next page it says arithmetic sequence. So arithmetic sequence is the sequence that we actually saw in the previous two pages, where okay, so let's look at the definition. A sequence where the difference between consecutive terms is constant and the difference is called as the common difference, and which is what we saw. What does this mean, D? So where I'm looking at the sequence which is 2, 4, 6, 8 and so on and so forth, it is a sequence, and this is an arithmetic sequence because the difference between the two, any two terms is constant and the difference is 2. So anytime there is a constant difference between the two terms, it is going to be an arithmetic sequence. So if you look at an arithmetic sequence with a starting value of a, and every other term you're adding a d, so this will be a, this will be a plus b, this will be a plus 2d because you're adding d to this, and then you're adding another d to this, so this becomes a plus 3d. So basically, if you look at the recursive definition, and again we spoke about recursive and explicit definition in the previous pages, recursive definition depends on the previous term. That's what we mean by the depends. That's what we mean by recursive definition. So if a1 equals a, that means the next term an is going to be an minus 1 plus d. So basically all we're saying is any nth term is the previous term plus d, where d is the difference. Whereas an explicit term, if we look at the explicit term, and just to kind of divert a little bit, both the recursive recursive formula and the explicit formula are under the arithmetic sequence formula. So here it says, so this is recursive, what I just spoke about, an equals the previous term plus d, whereas the explicit formula is you start with a1 and any nth term is basically a1 plus how many times d? You keep adding d how many times? You added n minus 1 times the d, which is what you will see here. This is, the second term is just 1d, 2d, 3d and so on and so forth. So this is, I'm just copying from here. It says this formula, this one is an is going to be a1 plus n minus 1d. That's the formula for the explicit definition. So explicit definition is you can get to any an. It's a formula for getting to any an. Okay. Let's quickly look at the first example. Decide whether the sequence is arithmetic. So let's look at the first one. If so, find the common difference and write the next term. Okay, that shouldn't be too difficult if it is an arithmetic sequence. So for the rule for the arithmetic sequence is the difference between the two terms has to be constant. So 7 minus 4 is 3. So 10 minus 7 is 3. So this is 3. This is also 3 when I subtract. There's also 3, 16 minus 7. Yes. And b equals 3. And my next term is going to be 19. Because 16 plus 3 equals 19. Let's look at the next one. 6 minus 3 is 3. But 12 minus 6 is 6. So I can straight away say no, because there has to be a difference. Here, this is a sequence. You can all notice that this is a sequence. It's just not an arithmetic sequence. Not an arithmetic sequence. Because arithmetic sequence requires a d. Okay, but it is a sequence because there's a pattern, right? There's a pattern, so that it is a sequence, just not an arithmetic sequence. Here it says, the question is, write an explicit formula for the nth term. Okay, so I know from my formula sheet, if I go back to my formula sheet says that explicit formula is basically any an equals a1 plus n minus 1d. I'm just looking at my formula sheet and getting this. As long as you understand that any nth term is explicit. an equals a1 plus n minus 1d. I'm pretty much looking at the same formula. And let's look at this. I need to find, what all do I need to know? I need to know a1 and I need to know D. So I know A1 is 2, but what is my D? When I go from 2 to 0, I'm going down by 2, so my D is actually negative 2. 0 to negative 2, negative 2 to negative 4, so my D is negative 2. So my AN equals 2 plus n minus 1 times negative 2. And let's simplify this. This is equal to 2 plus negative 2n plus 2. So which is what? Negative 2n plus 4. And then it's asked us, I'm so sorry, here we go. Hopefully you can see this. So I'm just simplifying that. And then it's asked us for A21. So A21 equals negative 2 times 21 plus 4. And we can all solve this and find the A21st term. Alright, hopefully we got this. Okay, so you're going to apply the same concept in each one of them, and it shows on the key as to how to do it. So hopefully I got this. So for you to write the explicit formula, you're going to start with this, writing down the explicit formula, finding what's A1, finding what D is, substituting it, and getting the explicit formula. Okay, I'm going to keep going. Let's go to the next page and see what they're asking us for. Looks like I'm losing focus. Just give me 1 minute and let's see if I can focus on this. Oh, there we go. So let's look at, so this one is actually very straightforward because they've given you the D, they've given you the A1, all you're doing is substituting. Let's look at something that's a little more complex. So if I look at E, what do I notice? I do have the D, but I don't have A1. So okay, let's first things first, let's write down the explicit formula. What is the explicit formula? A1 plus n minus 1D. So remember what you need. You need A1 and you need D. D is given to me, but how do I solve for A1? Okay, so instead of A1, what they have done is they have given me A4. So I'm going to use this A4 when n equals to 4 and solve for A1. So when n equals to 4, an equals 80. A1 is my unknown. N minus 1 is 4 minus 1. And I know D to be negative 12. And then you're going to solve for this. 80 equals A1 plus 3 times negative 12. That's going to be negative 36. Therefore, A1, I'm just trying to save space. A1 equals 116. Just solve for this equation and you should find A1 equals 116. Now I have enough information to write the explicit formula. So AN equals 116 plus, if we're writing the explicit formula, so n stays as n. And my difference is negative 12. And always a good idea to simplify it. So if I simplify this, this is going to be AN equals negative 12n plus 128. Basically all I'm doing is 116 minus 12n plus 12 and that will give me this. So that's my formula. And then I think they had asked for what is A21. So you're going to just substitute negative 12 times 21 plus 128. Go ahead and put this in your calculator and you should get the value for A21. So if you look at F is very similar. They give you D and they give you A7. From A7 you will find the A1 by substituting it in the formula. You'll do the same thing that you do. So F is very similar to, they're very similar to each other. You can solve these two from each other. Alright, let's keep moving. Next, if I look at G, I see that G, what I have is I have two terms in my sequence, A4 and A13, but D is missing. And remember, you need D for the explicit formula. But can I find it from here? Yes, I can. Yes, I can. I can do that. One way to do is going from A4 to A13, how many D's am I adding? Or one of the easier ways to do is, keep in mind, D is nothing but it's like a rate because it's a change of rate. So you can also do as y2 minus y1 over x2 minus x1, where y is the output. So 43 minus 16 over 13 minus 4. Basically, that's what you're looking at. Which is 27 over 9, which is 3. So D is similar to the rate of change, the slope. It's similar to the slope, because that defines the change of rate. Having done that, let's go ahead and see if we have enough information for the explicit formula. So explicit formula is A n equals A1 plus n minus 1 D. So I do have D, but I don't have A1, but I have two terms. So when n equals 4, I can solve for, when n equals 4, A4 equals 16. So I'm going to use this. So A4 equals 16 equals A1 is missing plus n minus 1 times D. So 3 multiplied by n minus 1. Sorry, n is 4. I'm so sorry. So in this equation only A1 is missing. So this is nothing but 3 times 3, 9. And then when I solve this, I should get A1 equals 7. So that means my explicit formula is A1, I have substituted here. Right, that's what I do. A1, I just solve for A1 plus n will depend on this n. Right, this n is which term are we talking about, and I have my D to be 3. Go ahead and simplify that. So when you simplify that, you should get 3n plus 4, because this is 3n minus 4, so this is 3n plus 4. That's your explicit formula. And then you are going to solve for A21 by substituting 3 times 21 plus 4. You can put this in your calculator and solve this. Alright, so when you're given two terms, your first job is to find the D. Once you find the D, you go back to how we did it in E and find A1, solve for A1. This is H is similar to this. So you can do the same thing. You've been given two terms, so you can solve for D first. You first do D and then you solve for A1. And then you can go from there. Alright. Let's keep going. I think I can probably do one more before I end this video. So it says find the first term of each recursive sequence. So here they've given us a recursive sequence. Why have they given us a recursive sequence? Because they've given us a recursive formula, because they've given us a formula which is an is based on the previous term. So I start with 3 is my first term. And then A2 equals an minus 1, which is 3 plus 5, which is 8. Then A3 equals an, the previous term, 8 plus 5, which is 13. And so on and so forth. So you can finish the sequence up. Alright, so hopefully we are using the recursive formula. You can always find the next term by going to the previous term. Alright, we'll stop this and I'll pick up the next page from the next video.